In the vast expanse of our solar system, there exists a mesmerizing giant, a world shrouded in beauty and mystery. Welcome to a captivating exploration of the motion of the planet Saturn. Although the solar system includes 8 planets that were formed billions of years ago from the same basic interstellar stuff, it is no exaggeration to state that each member of this octet is genuinely unique. Given color images and basic data about the planets and a few hours to study them, and any eager student in the making could quickly identify them on the basis of their appearance alone. Although it might be possible to confuse Uranus with Neptune in some cases. It is also no exaggeration to say that one planet's unique features stand out from those of the other planets in a way that its celestial competitors cannot match. That planet is Saturn, and that feature is Saturn's visually stunning and distinctive ring system. Saturn's rings can't be seen with the unaided eye, however, even though the yellowish-looking planet itself appears brighter than all but a handful of stars in the sky. This did not stop the people of ancient Greece and elsewhere from producing myths about, and imparting special characteristics to, the 6th planet from the Sun, including explanations of Saturn's movement that made perfect sense at the time but now appear hopelessly quaint in the light of modern astronomical knowledge. The Solar System. The Solar System, which, as astronomers now know with certainty, is really just a solar system, one of many identified in the Milky Way Galaxy, is centered, as the name implies, by the Sun, Latin word Sol, an ordinary star that accounts for the overwhelming majority of the mass of the entire solar system. In addition to the Sun, the solar system, almost entirely by chance, contains in effect 2 sets of 4 planets, one inside the asteroid belt, the relatively tiny terrestrial planets, and the other outside of it, the bloated gas giants, or Jovian planets, Jove being an alternative name for the Greek god Jupiter. The innermost planets are Mercury, Venus, Earth and Mars. After the asteroid belt comes the 4 giant planets, Jupiter, by far the most massive planet, Saturn, Uranus and Neptune. The solar system also includes a number of comets, some with very long periods, some of which pass within a short distance of the Sun just once before zooming out into the far reaches of the solar system's arbitrary edge. Pluto was once the 9th planet, but was demoted to a dwarf planet in 2006. Saturn. Facts and figures. Saturn is not the most distant planet that can be seen with the naked eye. That honor belongs to Uranus, though spotting that world and identifying it as a planet requires both keen eyes and foreknowledge of Uranus's status. To the untrained, it looks and behaves for all the world like a faint, 5th magnitude star. But Saturn is bright, and was unmistakable as a planet to ancient observers as much because of how rapidly it shifts position against the general background of stars. Galileo Galilei was the first to see Saturn through a telescope, in 1610. Because his telescope was primitive though of course a marvel in its own time, the rings appeared as fuzzy lumps on either side of the planetary disk, and Galileo sketched these as if they were small, twin companion planets. Later in the 1600s, Christian Huygens ascertained that the structures were rings of some sort, but neither he nor anyone else had a clue what they might be composed of. Saturn is about 890 million miles from the Sun, just under 9 times as far from the home star as Earth is. Its diameter is over 72,000 miles, again, about 9 times that of Earth. Finally, Saturn's day is only about 10.5 Earth hours despite the planet's massive size, meaning that its rotational speed must be correspondingly impressive. And it is. Given Saturn's circumference of 227,000 miles, the equator is whizzing around at about 20,000 miles an hour, 20 times Earth's equatorial rotational speed. What are those rings, anyway? The 1600s unfolded during the scientific revolution, which is generally taken to have begun in 1500 with the work of Nicolaus Copernicus. Given that this was a time of extraordinarily rapid knowledge acquisition across a variety of disciplines, it should perhaps not come as a surprise that, between 1610 and 1675, telescopes had improved by so much that Saturn's rings not only were evident as such, but boasted granular features that were already discernible even if their basis couldn't be grasped at the time. One of these features is the Cassini gap, named for the Italian scientist who discovered it. When you look at an image of Saturn shown from a typical oblique angle, the rings together appear to have a width of about 1/4 to 1/3 of Saturn's total diameter. About 3/5 of the way to the outer edge of the ring from its inner edge, a dark gap appears as a result of the gravity of the nearby Saturnian moon Mimas disrupting the ring elements. The Cassini Gap is about 3,000 miles wide, about the width of the continental United States. Saturn's rings are composed mostly of water ice, with individual pieces ranging from tiny fractions of a meter in diameter to over 10 meters wide. There are actually 7 distinct rings in all. At certain points in Saturn's orbit, the rings are edge-on, as seen from Earth, and are thus harder to visualize from terrestrial observatories. The moons of Saturn. As of 2019, Saturn boasted over 60 moons. These natural satellites are extremely diverse in size and composition. The largest of these, Titan, is larger than the planet Mercury, and is the second largest moon in the solar system behind Jupiter's moon Ganymede. It is surrounded by a sufficiently dense atmosphere so that the phenomenon of smog, or haze, has actually been recorded. Some of the smaller moons share characteristics with the components of the rings, as they are largely made of ice as well. One of them, Iapetus, has one very dark hemisphere, half, and one bright white side, giving a unique, killer whale sort of appearance. Other Saturn trivia. Saturn is made mostly of hydrogen and helium, which also happen to be the 2 main elements in stars. Some scientists believe that if Jupiter and perhaps even Saturn had been able to accrete slightly more mass during their formative periods, they might have had the potential to develop into stars in their own right. Saturn does not have a surface per se, being composed primarily of gas. Like Earth and the other terrestrial planets, it possesses a liquid core surrounded by a solid layer of nickel and iron outside the core. Its surface gravity is only slightly greater than Earth's despite Saturn's considerably greater mass, mainly because the planet's density is so low. Saturn exploration, past and present. When the Voyager 1 and 2 space probes were launched by the US months apart, with the second lifting off in 1981, scientists anticipated a wealth of new knowledge, as the probes were slated to pass very close to most of the outer planets in the solar system for the first time. They were not disappointed, and Saturn proved to be, and continues to serve as, a very rich astronomical learning environment. Saturn movement in the sky. Imagine what happens from the standpoint of Earth when an observer looks at one of the outer planets over a period of months or years. Because the outer planet's orbit is so much bigger, the Earth is continually catching up to the outer body. And after a time, the Sun, Earth and the planet in question all lie in a straight line. Then, the Earth starts to move in the opposite direction as it completes its orbit, relative to this line, while the outer planet is continuing its own lazy arc. 6 months later, Earth again is moving in the same basic direction as the outer planet. The sum of this activity is that, relative to the apparently motionless background stars, Saturn at times appears to stop, reverse direction in the sky for a few months, and then return to its usual motion. This apparent backward celestial motion is called retrograde motion. As you might expect, it was extremely confusing to early observers who believed that Earth, not the Sun, sat at the center of the solar system. How do planets really move? If the other planets took exactly as long to orbit the Sun as the Earth does, i.e., 365 Earth days, the outer ones would be moving at startling speeds through space. Although, granted, it could be argued that they already do. The tangential velocity v of a body in circular motion is related to angular velocity omega by the equation v equals omega r, where omega is in radians per second or degrees of measure per second. This means that the speed a planet is moving is directly proportional to its distance from the Sun. If the angular velocity omega were the same for every planet, Saturn, which is about 10 times farther from the Sun than Earth, would be moving through space 10 times as fast. The astronomer Johannes Kepler determined through painstaking math and the study of ellipses, since planets move in elliptical orbits rather than perfectly circular ones, that the square of the period, year, of any planet is proportional to the cube of the semi-major axis of its orbit. This means that a planet's year can be predicted from both the shape and distance of its orbit, and data has borne out Kepler's predictions very well over time. Saturn transit dates in 2019, Sagittarius. Humankind now possesses vast and detailed knowledge about what the stars and planets are, what they are made of, where they came from and how old they are. The heavens are such a compelling and enchanting subject that mystique and folklore surrounding the alleged influence of the placement of astronomical bodies on human events is a multi-billion-dollar industry called astrology. Though mostly for entertainment purposes in daily horoscope sections of newspapers, some people take signs from the heavens very seriously. Thank you for joining us on this cosmic exploration. If you found this journey as fascinating as we did, don't forget to like, subscribe, and hit that notification bell to stay tuned for more celestial adventures.